All right, welcome to The Explainer. Today, we are going on an absolutely epic journey. We're going to connect the single biggest event in the history of everything, the creation of the entire universe, all the way down to the dirt in your own backyard. It's a story that stretches across 13.6 billion years, so yeah, let's dive right in.
This is where it all started, 13.6 billion years ago. Before this moment, as far as we can tell, there was, well, nothing. And in the instant after, there was everything. This one number. It's the starting pistol for every star, every galaxy, every single thing in our entire cosmic story.
So how did it happen? Our best explanation is the Big Bang Theory. Now, the key thing to get your head around is that this wasn't some explosion in space like you'd normally picture. It was the explosion of space itself. Just try to imagine a single point, infinitely hot, infinitely dense, containing all of reality, and then suddenly it started expanding. This wild idea came from a Belgian priest and physicist named Georges Lemaitre, and it was backed up by Edwin Hubble's incredible discovery that, yep, other galaxies are all flying away from us. It's the very foundation of how we see the universe today.
Okay, so from that insane cosmic blast, matter started to cool down and clump together. But how did we get from that chaos, that primordial soup, to our nice, neat, relatively orderly little home, the solar system? Well, it took a few billion years, and it's this amazing story of gravity just doing its thing.
So fast forward to about 4.5 billion years ago. This is when our solar system gets its start, and the idea is called the nebular theory. Picture this, a massive, swirling cloud of gas and dust just hanging out in space. Over millions of years, gravity starts pulling it all inward. The center gets denser and denser and hotter, until, bam, ignition. Nuclear fusion kicks on and our sun is born. And all the leftover stuff? It gets flattened out into this spinning disk, where little bits of rock and dust start colliding and sticking together, growing bigger and bigger, eventually becoming the planets, moons, and everything else we see today.
And that star, our sun, is the absolute, undisputed king of this neighborhood. I mean, it is so ridiculously massive that it makes up over 99% of everything in the entire solar system. The planets are just cosmic leftovers. It's basically this giant ball of hydrogen and helium firing off non-stop nuclear reactions. It's a total powerhouse, and it's the anchor that holds our whole system together and gives us the light and heat we need to, exist.
All right, now that we've met the star of the show, let's take a quick tour of its entourage, the family of worlds that are all caught in its massive gravitational field. We've got 8 planets, and trust me, each one has its own very distinct personality.
You can pretty much split our planets into 2 distinct families, or maybe 2 different neighborhoods. This division was all shaped by the heat from the young sun. Close to the sun, where it was really hot, only the heavy, rocky stuff could stick together. That gave us the terrestrial planets, small, dense little worlds, like Mercury, Venus, Earth, and Mars. But farther out, past the asteroid belt, it was much colder. This allowed all the lighter gases to clump together into the massive Jovian planets, or gas giants: Jupiter, Saturn, Uranus, and Neptune. So let's do a super quick flyby. First up is Mercury, the little speedster just zipping around the sun in 88 days. Then you've got Venus, often called Earth's twin, but it's more like an evil twin, trapped under this toxic, crushing atmosphere. Next door is Mars, the famous red planet, which is literally red because its soil is full of rust. Then, past the asteroid belt, you hit the king, Jupiter, an absolute behemoth with a storm bigger than our entire planet and more moons than anyone else. Of course, there's Saturn, with those breathtaking rings made of ice and rock. And way, way out there is Uranus, the real oddball of the group, spinning on its side, basically rolling its way through space. Each one is a totally unique world.
Okay, after that grand tour of the solar system, it's time to bring it all back home. Let's zoom our focus way in on that third rock from the sun, the only place we know of for sure that has life. Our little blue marble, Earth.
So first things first, what shape is the Earth? We all learn it's a sphere, right? But that's not quite right. The technical name is a geoid.
What that means is it's a little bit squashed at the poles and it bulges out around the equator. And why? Well, it's this constant tug of war. As the Earth spins, centrifugal force is trying to fling everything outward. That creates the bulge. But at the same time, gravity is pulling everything relentlessly inward, which squashes the poles. It's a tiny difference, but it's real. You're actually a little bit farther from the center of the Earth when you're standing on the equator.
Now, let's talk about the actual ground beneath our feet, the Earth's crust. If you were to break it down chemically, you might be in for a surprise. The number one most common element isn't a metal or a solid. It's a gas, oxygen. It makes up almost half of the crust's entire mass, but it's chemically locked up inside rocks. Number 2 is silicon. Put those two together and you get silicates, which make up most of the rocks on the planet. And the most common metal? That'd be aluminum.
Okay, here is a really fundamental question about living here. Why do we have seasons? Now, a lot of people think it's because our orbit takes us closer or farther away from the sun. But nope, that's actually not it at all. So what's the real reason? The answer is all because of this one simple number, 23.5 degrees. That's it. This is the tilt of Earth's axis. It has absolutely nothing to do with how far we are from the sun and everything to do with the angle of the sunlight hitting us. This tilt, this lean, is the one and only reason we have seasons.
And because of that tilt, think about what happens as we circle the sun. During a solstice, one hemisphere is tilted directly towards the sun. It gets the most direct sunlight, giving it the longest day of the year, and that kicks off summer. 6 months later, that same hemisphere is tilted away from the sun, giving it the shortest day and the start of winter. And right in between those two extremes, you have the equinoxes. That's when the tilt is perfectly sideways to the sun, and the whole planet gets pretty much equal hours of day and night.
So far, we've gone from the Big Bang all the way to the changing seasons on Earth's surface. For this last step in our journey, we're going even deeper. I mean, literally deeper. We're going to dive right under the crust to check out the incredibly powerful forces that are constantly changing our world from the inside out.
If you could peel back the layers of our planet like an onion, you'd see it's a super dynamic place. We live on the crust, which is this really brittle, paper-thin shell. Beneath that, you've got the mantle, a huge layer of hot, dense rock that has this crucial, sort of plasticky, semi-molten zone. And right at the very center is the core, a blazing hot ball of nickel and iron, with a liquid outer part and a solid inner part that acts like the engine for Earth's magnetic field.
Now, that solid outer part of the Earth, the crust and the very top of the mantle, which we call the lithosphere, it isn't one solid piece. It's actually shattered into a bunch of massive slabs, and we call them tectonic plates. And these giant plates are always moving, kind of gliding and bumping around on top of that weaker, gooey layer underneath. This single idea is the grand unifying theory of all geology, plate tectonics. So what happens when these giant plates start moving around? Well, they interact at their edges in 3 main ways. At a convergent boundary, they crash right into each other. That collision can push up huge mountain ranges, like the Himalayas. At a divergent boundary, they pull apart. When that happens, magma from the mantle rises up to fill the gap and creates brand new crust, like what's happening in the middle of the Atlantic Ocean. And finally, at a conservative boundary, they just slide horizontally past one another. The friction builds up all this stress, which eventually gets released in the form of earthquakes, just like along the San Andreas Fault.
Okay, we have covered a ton of ground, from the birth of the entire universe to the churning engine inside our own planet. So after all that, what's the big picture here? What's the thread that connects the Big Bang to a rock in your backyard?
You know, the takeaway is really this. We live on a dynamic, restless, constantly changing planet that is the direct result of this incredibly long and complicated chain of events. The very elements that make up our world were forged in the hearts of dying stars. The gravity from a collapsing gas cloud lit our sun, and the heat left over from Earth's formation is still driving the movement of continents today. Every single thing about our world, every mountain, every ocean, is a chapter in a story that started 13.6 billion years ago. We are, quite literally, living on a piece of cosmic history.